Hello, everyone, and welcome to The Vertical Space, a podcast at the intersection of technology and flight. We are your hosts, Jim Barry and Luka Tomjanovic, and here we look at the most important forces shaping the market of advanced air mobility, with a particular focus on why and how they matter to those building a business in this very exciting and growing industry.
What makes us uncomfortable are $1 million airframes flying around with $200 autopilot that, although has in general had very good flight experience and has some probably the best software out there for controlling a lot of variety of airframes, it is also can be susceptible to the connector being plugged and unplugged too many times.
When we got answers about here's how you go certify avionics, we looked at it and said, well, that's not going to work for us. We have to figure out a different way to do it. And so there's a negotiation between the regulator and a startup organization and saying, no, we're not going to do it the way you normally used to it. We're going to do it differently. And somehow we pushed through that.
Hey, everybody. Welcome back to The Vertical Space. Today, we welcome Christian Ramsey and Ryan Braun from uAvionix to discuss next-generation avionics. Ryan and Christian lead a successful company with real products for clear industry use cases, in this case with size, weight, and power-optimized avionics, while straddling both the manned and unmanned markets. Listen to their conversation on the benefits of being in both markets. This is so important as we hear from so many who have yet to build their capabilities, are hoping for a variety of conditions that may or may not occur with use cases that have yet to be proven. The uAvionix approach speaks to the benefits of building capabilities that have a rapid return on investment in today's markets for today's needs, while creating capabilities in unmanned markets that, yes, exist today and have the potential to rapidly and expansively grow in size and scope. We talk about technologies necessary for the integration of UAS into the airspace system: autopilots, command and control radios, high-integrity GPS receivers, cloud-based beyond visual line of sight command and control networks, and ADS-B. You'll enjoy hearing about what drove the need for ADS-B and why it is so important to our industry and for the foundation of uAvionix, why it is and isn't a good option for small drones, yet so important for manned aircraft. We discuss the advanced air mobility supply chain, the role of certified avionics in the unmanned aircraft industry, as well as lessons learned in building and selling a profitable and fast-growing avionics company, serving, as I said before, both the manned and the unmanned markets. One of the reasons that uAvionix has been successful is that it took an established capability and introduced it to markets with clear use cases. Listen to how they took their tech to smaller airports, where a lot happens on ramps and taxiways, and where coordination is historically through verbal communication. ADS-B brings the same benefits to an airport that it brings to aircraft, helping to prevent, in this case, ground incursions, and providing a full range of intelligence, including where aircraft come and where they're going, as well as providing runway friction information. And rather than building their own business intelligence platforms and selling them through this vast market, they partner with companies that already have their own platforms and broad market acceptance, as represented with the recent market announcement with their partnership with Passer Aerospace. Finally, listen to the importance of growing a viable, profitable company from the outset. Listen to their advice on the importance of running profitable operations from the beginning, which builds a stronger and more attractive opportunity should the time be right to raise funds for more expansive opportunities. You'll enjoy listening to their experiences in the early days of their business. By way of background, Christian Ramsey is the president of uAvionix and a member of the FAA Drone Advisory Committee since 2020. Christian's career includes positions at Harris Corporation, ITT, Rockwell Collins, and NLX. He started his career as a software engineer with Lockheed Martin. Ryan Braun has been enthralled with airplanes and technology since he was young, finally landing a paying gig as chief operating officer of uAvionix, a company that specializes in groundbreaking avionics for general aviation and uncrewed aircraft. Ryan is a private and remote pilot and is heavily involved in the certification of uAvionix products. Thanks, Christian and Ryan, for joining us. And to our listeners, we hope you learn and enjoy from our conversation with Christian and Ryan as you innovate in the vertical space.
This episode of the Vertical Space podcast is brought to you by uAvionix. uAvionix is the leader in low size, weight, and power certified avionics for manned, unmanned, and advanced air mobility aircraft. Let uAvionix help you achieve your goals, whether that be type certification, airspace access, or beyond visual line of sight operations. uAvionix has certified and certifiable communications, navigation, and surveillance avionics for your aircraft. So head over to uavionics.com or Google it to see how you can start flying safer and move your platform forward into shared airspace. we've been looking forward to having you guys on the podcast for a while now, especially since you're our launch sponsor, which we appreciate sincerely. So lots to talk about the interesting world of avionics. But before we jump into the deep end, is there anything that very few in the industry agree with you on?
We've kind of come into the industry with a different viewpoint than some. We've got a pretty good aviation background, but we've also straddled the line and are a pretty typical Silicon Valley startup. And because of that, I think we've always had this mindset around integrity, but the ability to move fast and create product quickly with integrity. So there's people in industry on both sides of that spectrum. If there's a disagreement, it's that we sit in the middle and we try to bridge that gap. And GPS integrity is one of those things that we've really trumpeted. And the other is ADS-B. We've been a proponent of an active detect and avoid system since the start, and have really championed the integration across all platforms, both to receive and send those ADS-B signals to help detect and avoid. So I wouldn't say everyone disagrees with that, but I would say we're out front more than anybody from the founding of our company with saying that that's a really effective way, a cost-effective way to move the industry forward. Christian?
I've actually got a couple. One is, I don't think 5G is going to solve everything the way that many in the industry have hoped. There's going to be a whole series of spectrum solutions that are required. 5G and LTE are going to be important, but I think there's been too much importance placed on how that's going to solve connectivity for advanced air mobility. The second thing I would say that we don't agree on is piggybacks a little bit off of what Ryan said there, which is, from a detect and avoid and UAS integration into the airspace perspective, we've gotten not very far because we're trying to integrate and not interfere and enforce changes on the existing users of the airspace. And I think we're getting to the point where trying to work around those that choose to be non-cooperative in their aircraft technologies, whether they're broadcasting ADS-B or I guess mostly ADS-B, but I suppose it could be something else. It's just becoming too much of a barrier to moving progress forward. So pushing, and we're private pilots too, right? And we understand nobody likes to be told they've got to put something on their aircraft, but the partial equipage of ADS-B around the world is a barrier to making the sky safer and moving things a lot faster.
Can you give us just a high-level 30,000-foot view of uAvionix?
I'll tell you where we started. We started in a very, very focused manner of developing ADS-B for drones. That was our first mission and our first seed funding effort to go develop that technology. As a pilot in 2015, we understood the ADS-B mandate that was in place, but yet still 5 years away, and understood the potential that brought to a cooperative airspace, and understood that miniaturization of that technology, whether it's transmit or receive, was going to be a critical component to enabling commercial drone operations. That's where we started. From there, we have grown in markets. So we've expanded into general aviation. We have products for airports. We have products now for defense and products for civil UAS. We've expanded products to include GPS, autopilots, command and control radios, and we've expanded in our capabilities in terms of certification capabilities. So we really upped our game when it comes to producing, high quality solutions where, early products we could probably categorize as hobby grade or slightly above, but we've grown significantly in that. So at the highest level with an umbrella, I would say that we are, an avionics manufacturer that is focused on all of the critical components that enable a drone, call it a drone here, to fly safely and achieve its mission. Not the payload components, not even the airframe, but all of the critical components that keep that system in flight.
Christian, what was the business gap or the business opportunity that you saw that was so attractive when you first designed it for drones? And I would imagine the ADS-B out requirement was a great opportunity for general aviation aircraft.
The gap at the time, back in 2015, was size and cost. I mean, so the the ADS-B systems on the market were only coming to market around that time frame, right? The mandate was announced in 2009, I believe, and wasn't due until 2020. And in that first 5 years, all of the initial development in the industry occurred, and there were only a couple products that were even on the market that could do ADS-B, especially for general aviation. But they were still 4 or 5 pound CB radios that slid into the dash cockpit of a Cessna, and so that's not tenable. So a miniaturization component was one of them. The second being cost goes along with volume. There were huge projections of delivery drones and inspection drones and hundreds of thousands of these things buzzing around the sky. And so if you factor in the volume component as compared to what's going on in general aviation, which produces about 1,000, I think, Ryan, aircraft a year.
Yeah, 1,000, 2,000, depending on how you
then your math and your initial investment to miniaturize can play out the business plan.
Yeah, I mean, when we look at the consumer electronics space, and you go off and you try to talk to a component supplier, a silicon manufacturer, and you say, I want to build 1,000 of something or 10,000 of something, you get laughed out of the room. You need to be talking 100 million these days, right? So cell phone components, the things that everybody put in cell phones, trickled down into the early drone markets and enabled a lot of those technologies. So the IMU chips that really enabled those autopilots to come down in price did so because they put them in cell phones and they were making hundreds of millions of those. What is the corollary? How do we do that into a space like detect and avoid, right? There was no real opportunity to do that prior to we showed up. And when we did that, we really made that argument that we're going to be able to push significant volume because we are going to equip every participant in the airspace with some form of ADS-B. And we did that. We were able to miniaturize that solution down from that 4 pound brick box that Christian talked about down to a single chip solution. And that's what really cracked the door open and was our first product. And we've had great success with that. That first development that we did both showed that we could operate at that level and do those things. But it's been a radically successful product for us. That product, we've shipped over 600,000 solutions into the space, which is not hundreds of millions, but it's huge in the aviation market to be able to push that type of volume out there. And that's gone into everything from large manned aircraft to high altitude pseudo satellites down to the smallest drones on the market.
If you take yourself back to those early days in 2015 when you were convincing yourselves about making the investment in low swap ADS-B for detect and avoid, for integrating UAS into the national airspace, et cetera, what idea of the market did you have at the time, and how has it changed since then? What are the main ways in which the market fell short or exceeded your expectations?
When we were originally focused on just being a uncrewed UAS company, there were, as Christian said, and we all know from being in the industry, there were expectations of insane volumes in short order. We pretty quickly realized that we weren't going to be able to pin all of our hopes on that. We know, and we are 100% convinced that inflection point happens and that hockey stick does happen. And we see that. We have really good demand signals that come from our customers. We work with almost every aircraft maker out there. And we know that there are some, big things in the offing here, things that are brewing. But it's still a waiting game for a lot of regulatory approvals and things. So the market clearly didn't develop as quickly as we would have liked. And we responded to that by really diversifying our product lines and moving into areas that could be served by those same core technologies, and specifically, the manned aircraft space with the general aviation product line. So yes, the market's evolved and it's gone in different directions, but I think principally we're coming back around to what we talked about 5 years ago, 10 years ago as the possibilities for this. There's just been a lot more steps than people anticipated to get there. And those first products that we designed are still extremely relevant today and underpin a lot of what we do. Just because you make it small doesn't mean it can't meet all the same performance specifications.
Exactly.
and it can't be just as capable. This concept that you have to have a big box to do these things is outmoded and outdated, and that is not how anybody is going to succeed in these industries, especially as the larger GA industries, manned aviation, civil aviation, all of that merges, and we're trying to figure that out. Everything from the air traffic control side all the way down to the avionics in the aircraft is how do we bring these two very disparate technology stacks together. But at the end of the day, the technology that we're putting in these aircraft, they're going to have to meet the same performance standards. So that's always been our principal goal, is that we design something that can move up and down that stack, and that we can design a lot of things around, because it's cost effective and it just makes sense.
Ryan or Christian, if you could, for our audience, some of this may be new to them, just describe a little bit of when you said you wanted to create an ADS-B for the drone or for the general aviation aircraft. Why was that an opportunity? What's the service you're actually providing to the drone or the GA aircraft, and why is it so important?
Before I joined uAvionix, I was a program manager on a program establishing the ADS-B network in the U.S. With the FAA was a customer of mine, and what the concept of ADS-B is, and they were throwing around the term next gen air traffic control in those years, right? Because really what ADS-B is about is providing some fidelity to know where the aircraft are in the sky. The previous generation and in other parts of the world, current generation of air traffic control, where we know airplanes are is through the use of radars. Radars are very expensive, and you probably don't really know that they're not hugely accurate, right? You've got a big spinning antenna transmitting energy, it bounces back, but you can only get so accurate. And that's why in an air traffic control world, there's a separation. You can only literally fit so many aircraft in the air because you have to keep 5 miles of separation between every aircraft, right? I mean, you've got to have a large distance. So the idea behind ADS-B was, let's replace that older technology with something new. And the something new is, instead of a big thing on the ground trying to detect the airplanes in the air, let's put something on the airplane that tells everybody else where it is. So it's, at a very simple explanation, it's a GPS receiver that transmits its latitude, longitude, and altitude and an identifier to anyone that listens, and it's in a manner that is receivable by anybody that wants to, right? And so it's received by other aircraft, it's received by satellites, it's received by ground-based systems, and it can be received by a drone if you can get that equipment low enough. So you now have a very accurate position of, hey, there's an aircraft 3 miles away from me. I better not head that direction, right? And so the idea of going from a sky where you don't know where the aircraft are because you don't have access to an air traffic control display, to something that very, very accurately and with 1 second update rates at a minimum, tells you where every aircraft in the sky is. And so that was a very powerful idea that, wow, if we knew where everything was, then that sure makes the job of avoiding them easier. And that should enable new modes of aviation.
And so I'll ask a market question. What's the size of the market if every general aviation aircraft and every drone today had your technology? What's the size of the market?
We've done this math. It's in the billions. Something that goes into A380 probably costs tens of thousands of dollars. Something that goes to a general aviation aircraft is a couple $1,000s. Something that goes into a drone might be tens of dollars, right? Or low hundreds of dollars. So I don't have a quick dollar figure for you there, but it's just the use cases are huge.
Ryan, you mentioned in your opening comments that the industry has a different opinion on the role of ADS-B for drones for the detect and avoid use case. Can you elaborate on this a little bit?
The industry has taken a couple different viewpoints on where ADS-B should fit into this equation, and that's everything from having ADS-B out on every aircraft, so that everything from the smallest drone to the largest airplane out there transmits and can be seen, to having no equipage on the aircraft. And so there's a kind of a measured approach that sits somewhere in between here, where all of the aircraft, we like to at least receive the information, even very small unmanned aircraft, because then they can see things to get out of the way. And there's a lot of commercial applications as well, where we would like aircraft to be able to transmit even large unmanned applications. So we have a lot of customers who equip high altitude aircraft or balloons, for example, that are going through Class A airspace with jetliners. It's really good that they can both see and avoid each other. There are some concerns, though, specifically regulators that are uncomfortable managing large volumes of aircraft that they haven't in the past. So if there's this fear from the start that if you have hundreds of thousands or millions of new aircraft added to the system and they showed up on controllers' displays, that it was going to overwhelm them. That's a legitimate concern, but something that, of course, can be addressed with technology. And then there's also been concerns around the cost to equip all of those aircraft, which we see even from owners of general aviation aircraft who don't necessarily want to foot a bill to enable someone else's operation. So there's been a lot of different looks on how this can all evolve and how we can end up with something that really makes sense. There's even concerns that you just won't get the entire picture, and that really has been one of the big pushback. If you have non-cooperative aircraft out there, you need a radar to see them. So if they don't equip, and that's why what we've done more than anything is try to bring that cost of equipage down, to give people an opportunity at a low cost to increase their safety margin.
What does it take to convince the industry to adopt a certain technology? And maybe this is not necessarily specific to ADS-B, but you guys have been very vocal about very low power ADS-B for drones and not continuous transmission, but only when necessary. So how do you take a value proposition and reach consensus in the industry that this is a good idea?
I think each country is a little different regulatory landscape. We've certainly participated in a lot of those industry conversations around this. Internationally, some of these frequencies are pretty full. And so again, there's a fear that, there might be an interference because too many drones show up. And to counter that, you mentioned a technology that we've discussed a lot and proposed called inert and alert. And that's a technology whereby an unmanned aircraft can listen at all times, looking out for other aircraft. And if that manned aircraft gets close, they will start broadcasting, basically say, "Hey, I'm over here." And this is really important, maybe not as much for the jetliners at 30,000 feet, but for medevac helicopters, things like that, flying into austere locations or different locations that aren't typically takeoff and landing zones for aircraft. So, we think we have some really good technological solutions for that. But there's always a lot of different forces in the industry and in the regulation that feel there are better ways. And there are a lot of developments going on to kind of assign dedicated frequencies, dedicated technologies, and really kind of separate off the manned and the unmanned spectrum for that. What we don't like is not having this available to everyone. What we don't like are proprietary protocols, right? We like international standards that anybody can build anything to. And as long as it's that, we're good with it. We've been we talk a lot about ADS-B, but as a company, we end up being pretty open and pretty diverse with the technologies that we've implemented and supported. We think ADS-B is great, but we do a lot of other things in communications technologies, C2, and we work with those standards. That's the key thing, right? We don't want a proprietary non-interoperable technology for something as important as detect and avoid.
Mm-hmm. I can give you some examples of how diverse the global thinking is, though, right? So the FAA's rulemaking for remote ID made some changes to Part 91, which is the general airspace rules for manned aircraft and I guess unmanned aircraft as well. But it defines the ADS-B mandate and who equips and who doesn't. So the FAA has effectively banned ADS-B on anything under 400 feet for sure, under Part 107 for sure, but any other aircraft in any other airspace unless it is operating under an air traffic control services. So unless it it flies and smells and sounds and looks like a typical airplane from the FAA's perspective. You won't have ADS-B on board.
And just to caveat that, Christian, it's ADS-B out. So
ADS-B out,
they encourage everyone to listen to ADS-B,
yeah,
but to transmit it, they've started to put in some restrictions.
So a little bit of technical detail here, but ADS-B in the US operates on two different frequencies. There's a frequency called 1090 megahertz, which is what most of the world uses for transponders and radars and ADS-B. And then there's one in the US that we use called 978 megahertz, which really is today only used by the US, right? So this is a frequency that is dominated in the US by general aviation usage. So it's almost a general aviation versus commercial aviation split. But it doesn't matter to the FAA. Either frequency, can't use it. Other countries are looking at it differently. UK and increasingly Canada are saying, we don't use that UAT frequency, but maybe we should. Maybe we should keep all of manned aircraft on 1090 and move to UAT frequency for drones. So there's this new idea that, hey, we can repurpose what was done in the US with a 2-frequency system, but split up the users on those 2 networks. And CAA is about to make some, they've published already some future airspace strategy documents that point in that direction. And there's been some activity that we've been involved in that direction. Europe has said, EASA has said, let's create something completely new. And we're going to call it ADS-B Lite, which is awful name, because they're trying to tie it to ADS-B, but they're using a completely different frequency, an open ISM frequency, but they want to call it ADS-B Lite. And so they've been talking about how they might be able to use that in U-space environments. And of course, back to the US here, we've got remote ID, which is, you could think of as a competing technology in that it broadcasts a drone location, but the way that they've specified it is really not for detect and avoid purposes. It's a security mechanism and pretty short range given the frequencies that it operates on and the power levels that it operates on. But at least we're seeing signs now that the FAA has recognized that they've taken a powerful tool away with ADS-B, and that remote ID will not solve the surveillance problem. And so there's now talk within the US about a third protected frequency that they're currently just calling in general a vehicle-to-vehicle frequency that will perhaps do something very similar to ADS-B operating on a protected frequency with higher power and longer range capability. So it is all over the map right now.
How far do you think we are from implementing this third frequency potentially in the US?
Years. I mean, it's early exploration phases with some working groups and things like that. But it would need to move through. It would probably go through a special committee in RTCA, which had 2 years for that process to keep going. And then there's FCC rulemaking to go along with. We're seeing sort of a parallel in command and control right now with the new frequency allocation for C-band.
You mentioned earlier how this emphasis on non-cooperative detect and avoid is slowing down innovation. Can you shine some more light on that?
Yeah, I mean, in early days of and one could argue that this is still the opinion as well. In early days of the growing drone marketplace and integration into the NAS perspectives, there was a huge fear that drones were going to come in and be a danger to the NAS, the National Airspace System, and that we would need to create an entirely new airspace structure and rules of the air that would prevent that from happening. So essentially integration by separation, right? Certain airspaces would be used for drones and certain airspaces would be used for manned aircraft. And understandably, that caused a lot of fear and backlash by regulatory groups like AOPA and advisory groups. I'm not sure if regulatory groups is the right way, but advocacy groups, I guess. And so the stance became, whatever we do, we're not going to affect you at all. Don't worry. We're going to make the drone see you and avoid you, and you're always going to have right of way. And don't worry about it. We'll integrate these into the airspace and put the entire impetus on the unmanned system. Now, from a technology standpoint and a cost standpoint, that's almost a deal killer for a scalable UAS commercial marketplace, because the technologies to detect what we would call the non-cooperative aircraft, an aircraft that doesn't have ADS-B on board, telling you where it is, are slowly coming along. And there's significant performance issues with them. There's camera-based systems, there's radar-based systems, and if it's not a performance-based problem, it might just be that it's too big and too expensive for kind of a small business owner to equip their aircraft with this technology. It increases the size of what the aircraft needs to be. I think there's some recognition in the industry now that that was a bit too hard lined, right? And so you saw that some indications of this coming out of the recent Aviation Rulemaking Committee ARC report on BV loss, beyond visual line of sight recommendations, which for the first time ever contemplated changing rights of way rules for manned aircraft and unmanned aircraft, and in some cases advocating that the unmanned aircraft should have right of way over the manned aircraft, leveraging ADS-B, right? So if the manned aircraft had ADS-B, they would have ADS-B out, they would have right of way over the drone. But in the flip scenario, if the manned aircraft did not have ADS-B out, the drone would have right of way over the manned aircraft. Now, is that really a tenable solution? I don't know if it is, but it is really interesting to see that the general attitude and the consensus that came out of that report, and some of the participants in that report, in that ARC committee, were those same advocacy groups. The recommendations that came out of that report start to see some potential movement in rights of way rules that may force existing airspace users to adapt to a growing airspace user.
And I was surprised to see that as well, that recommendation. And I was expecting a lot more pushback, or maybe there is, but it's just not reaching me. Where, just for the audience, to clarify, in addition to your comments, if you're flying below 400 feet in an aircraft, in a traditional aircraft, and you do not have ADS-B out capability, then it's on you to see and avoid drones. But if you're flying at the speeds at which traditional aircraft might fly at, you can argue that
Pretty hard to do.
pretty hard to see a small drone.
The people who would rightfully be concerned about that are the crop dusters. Right?
Exactly.
It always comes back to certain airspace users that have had fairly exclusive use of some of that low altitude airspace. And yeah, those type of changes are hard, but it's not hard to equip with some of these solutions. And we've always looked at it from a pure number standpoint. It sometimes approaches a level of absurdity, because there's been so much hand-wringing and so much effort put into the system, and billion to billions spent on the infrastructure, the ADS-B infrastructure of the United States. And we're talking about equipping a few 100,000 airplanes. The total equipage numbers right now are about 161,000 airplanes have equipped total in the United States. What's that out of? No one really knows, because registrations aren't always current. Could be some airplane that's been sitting on the tarmac for the last 4 years.
Right.
But generously hundreds of thousands of aircraft. And if there was really a concerted effort just to go equip everyone, it could be done inexpensively. That is what we really specialized in. We wanted everyone to equip, and we came out with the most affordable solution to try to make that happen. That we priced under a couple $1,000s and made it very, very, very easy to install. But if you thought that there was an order that could be placed to just go equip everyone, it could be done for much lower amount than that. If you could really do it and settle on a technology that you could do for a couple $100s, we're talking to equip hundreds of thousands of aircraft to be $40 million. That's a drop in the bucket compared to the money that has been spent on the system and the hand-wringing that has occurred over the years. So we always felt there's a good argument to lower the cost and equip everyone.
You guys serve both the unmanned and traditional aviation. How different is it being an avionics supplier to those two branches of the industry?
It's given us incredible credibility to be in both. And what we learned in early days is, if you approach the FAA and you say something to them like, hi, we're uAvionix and we're here to certify a transponder for drones, their jaws drop and they don't really know how to approach that. But if you go to them and say, we're uAvionix and we want to certify a transponder, period, okay, here's how you go about doing that. And you get the certification, and you get the STC, and now you've got credibility with the FAA that you know how to certify and build quality products and do everything that you need to do as a certified avionics provider. And now you've established that reputation with the FAA, and you go back and say, okay, now I'm ready to certify that transponder for drones. Okay, what's the difference between what you've done already and what you're going to do for the drone? So, it's given us a great amount of credibility to leverage what we've done in one market against another. Same story was when we entered into the defense market, right? We leveraged heavily the fact that we had TSOs and transponders in civil aviation, and we needed to add, the military modes to that. And they looked and said, oh, you guys have the TSOs for all of this stuff. Check, let's focus on the new things. From a marketing and sales perspective, it is completely different. A typical general aviation pilot is not your typical aircraft builder for a drone, right? There's age differences, there's capability, generally speaking, right? There's capability and understanding of technology differences, and how you sell and market to the different groups. We still struggle with, because we're engineers and we like to tout the technical specs of everything that we have, but general aviation pilot doesn't care. He wants to know what it does for him. Now, when we were selling to an OEM aircraft, then the technical specs are everything.
Setting aside the ADSB mandate, has it been easier to sell into the UAS world or GA?
Yeah, I mean, certainly there are traditional channels in general aviation that you just got to plug yourself into. There are distributors and resellers and shops. Now, we needed to earn our way into those channels by proving credibility, et cetera. They don't necessarily just want to represent everyone. So we had to earn our way in there, which we did fine. There is no such channel in the UAS market. It's either all direct or it's through resellers, and resellers of varying capabilities and credibilities around the world, really. So it's a little bit more Wild West in terms of how we sell.
What's your revenue mix between military, GA, and UAS, let's say?
It's probably 75% in general aviation, and military's still budding percentages because we're just entering into that market in the past year and a half, and the sales cycles take a long time. But yeah, 75% is general aviation.
And over the next 5 years, you see the same mix?
Over the next 5 years, we hope to see that even out, probably maybe 60-40 by the time we're at the end of 5-year period. 2020 was really interesting. Entry into COVID. We were always curious about what's going to happen in 2020 because that was the FAA's deadline. But nobody factored in COVID. But March 2020, the world shuts down. GA sales just plummet, and unmanned sales increase really for the rest of the year, right? So it was really weird,
Nice.
to kind of see how something like that can help prove the value of uncrewed systems, and it drove more product sales in that market. Our UAS products have never been flat. It's always been increasing from the beginning of time.
So when you look at the value chain of the traditional aviation markets, suppliers have consistently enjoyed a lot greater share of the profit pool compared to OEMs, for instance. Is it any different in the unmanned industry? And how do you think that this will change in the future?
There's a lot of vertical integration that's going on with the OEMs in the uncrewed space. There's also, when you look at some of these more advanced AAM type applications, the more UAM type applications, they're building organizations that are going to capture probably a lot of that value, because they're everything from the designer of the airframe all the way through the operator, right? And all the way down to building out communications networks possibly, and building out vertiports. So yeah, I mean, the traditional aviation, the crewed aviation space compared to the things that people are looking to do with AAM, I think is radically different on who's going to capture the profit. What I would say is that there is a lot of vertical integration going on with some of these companies, and sometimes that's good and sometimes it's bad. And we work with a lot of companies, and sometimes there's great ideas and poor implementations, and at the end of the day, they kind of come back and really need some of these certified avionics that we're building. So every company I've ever been involved in, there's engineers have a not invented here mindset, and I think this industry is stabilizing a little bit on which of these systems really demand these certifications, how they can effectively get there, because it's not always cost effective to go build them on your own. So I would say, to your question around the margins and the supply chain, with that, it's going to be probably a little more balanced, but you're also going to have companies that have a lot more breadth that aren't just an airframe manufacturer.
Guys, of the three markets you described, military, GA, and UAS, which one's the more competitive for what you do?
General aviation, for sure. I mean, there's just, more players in general aviation than that existed. Biggest market, but, there's experimental aircraft, there's certified aircraft. And so there's a decent number, probably a dozen or more pretty good avionics companies out there providing a range of products. And we are challenged in that market because we don't have as broad a range of products as some of our competitors do, where we don't do glass cockpits, large scale glass cockpits, for example. And when you've got a platform like that, you can bolt on additional features and functionality and boxes and capabilities. And that's something that will grow organically, capability over time to add more and more content there. In the defense market that we're in, there's really only one competitor that we compete against. And in the civil avionics market, there's maybe a couple in each category, right? But they're kind of differentiated differently. So, we've got competitor in transponders. There's 3 or 4 competitors in autopilots. There's a whole bunch of competitors in command and control radios, but they range from sub $100 hobby grade radios to tens of thousands of dollars, so it's a really different differentiation in that specific market.
Can we spend just a couple more minutes talking about the vertical integration that exists in the unmanned industry today, both forward, where OEMs are also operators of some of these vehicles, but also backward integration, where a lot of those building blocks technologies are being built in-house. And frankly, the reason is the supply chain is not evolved enough, and there's still a fair amount of hand-holding and educating of the end users on how to use these vehicles. So it makes sense to be vertically integrated in both directions. But at some point, that needs to change. And so what do you see as the inflection point, as the changeover point for where the supply chain really develops into a lot more complex and richer environment?
I think we're starting to get there with it. I mean, you hit the nail on the head there. It's when you're on the bleeding edge and you're out there trying to create these solutions and you don't have the catalog to go order these components from, what are you going to do? You're gonna build up that entire ecosystem. You're going to become overly vertically integrated to try to do that, especially from a systems perspective. So that's something that we've really focused on. And one of the things we talk about a lot as we certify these systems is how we can make them do box level certifications on things like autopilots, so that they can reuse a lot of those artifacts when they certify airframes. That's evolving, right? From a regulatory perspective, how some of those things happen and what specifications and what requirements you need to meet for these things is changing every day. And it's still not set when we look at the AAM industry and the changes to a lot of these eVTOL platforms for type cert, for UAM type people carrying applications. I mean, there's just so much in flux with that it's not really necessarily a technical issue with some of these, but it's how can we certify them? What's the regulatory path to that? And building up the supply chain and the ecosystem is critical to freeing us of that. I think it's going to be really hard for people to be successful with that high level of integration, just because there's so many difficult problems to solve at once. And we talk internally about the safety chasm, right? There's so many airframe manufacturers out there who've done an incredible job building up aircraft that you never thought could see the light of day. There's just so many cool variants and applications and platforms for these things. And then they get to the point where they want to use them in regular commercial use. There's some level of certification needed, some level of safety case. And how do they get across that? How do they cross that safety chasm, and how do they close that? And that's what we really try to do, is provide those tools to manufacturers so that when they go to operate in an environment and they say, well, you can't operate if you don't have a transponder, and by the way, that transponder needs to be certified. No company in their right mind is going to go develop that specifically for that, but those didn't exist previously.
Right. So on that note, when you talk about your customers, what major trends on the unmanned side are you seeing, and what do your unmanned customers really care about the most?
Command and control.
Command and control.
Maybe tying your last question to this one, though, autopilots are a key component of the vertical integration or not vertical integration. They autopilot / flight control computers. What we find or have found over time is there's a bunch of them out there. A lot of them are self-engineered, and part of that spans from the wide variety of airframe configurations and propulsion types that exist out there that didn't traditionally exist previously, whether they're eVTOLs or fixed wings or something between. There's a lot of complexity there, so they decided they needed to build their own flight control computer. As things have moved along, I've seen sort of the maturity in that autopilot flight control computer evolve to be able to handle those additional aircraft configurations and types. And so what our initial customers were very concerned with was, did our, I'll call them peripherals at that time, right? Do they work with the autopilot they have selected? That's the first and core component that they build trust in and fly their aircraft with. And compatibility with those flight control computers was, paramount to being successful and driving compatibility. We tried a strategy for a while to get those flight control computer autopilot manufacturers to adapt to our standards and our interface that we felt for one reason or another was superior to what existed, but it was a really pushing a wet noodle up a hill, right? It was really, really hard to get them to act. So, compatibility was increasingly important. Used to be that C2 radios were sort of interoperable, and kind of getting into where Ryan was talking about, right? There was a lot of C2 radio interoperability. Most of the frequencies were ISM, or industrial scientific medical, which means it's a kind of a public unlicensed frequency. And we've seen over time that regulators like the FAA have pretty clearly been saying, with increased frequency over the past couple of years, that this isn't going to be an approved solution moving forward for beyond visual line of sight. Therefore, industry, you're on notice. You've got to find other solutions. And so the other solutions are moving more towards protected spectrum components. Protected spectrum meaning there's not necessarily that it's harder to interfere with, but there's a lot larger legal implication regarding interference with that protected spectrum. So that pushes you towards something like LTE, 5G, or in one of our cases, a C-band radio, which is an aviation protected spectrum. So if you can think of spectrum along a spectrum. On one end of the spectrum, you've got low cost, right? Low cost but high risk, and that would be the ISM frequencies, right? You take the risk by flying on a radio that's operating in an ISM frequency because a whole bunch of other things, including garage door openers and phones and kids' toys, are all operating on that frequency, and Wi-Fi networks. You're taking a risk there by operating there, but it's the cheapest, lowest cost solution for you to be able to fly. On the complete opposite end would be something like the C-band. It's the most expensive because it has to have a TSO to operate on that frequency, but you're the most safe. LTE is kind of in the middle, right? LTE 5G is kind of in the middle. You've got a protected capability. It costs you something more than an ISM to operate there. So we're seeing more of a trend moving towards the serious operators looking for a solution that is approvable for their operations.
And they're looking for, a network to be able to really implement those operations. I think a few years ago, we started really getting those questions around well, where does the remote pilot sit, and how can I hand over from one remote pilot to another as they take off and then perform a pipeline inspection? So those logistical questions that hadn't really been addressed yet, there's a lot of hand waving over. We're getting to that point now, and so solving the problem of how you remote pilot these aircraft is something that we've really taken on with a product that we call Skyline, and it combines the hardware, these radios that Christian's talked about, these both ISM band radios, C band radios, even LTE radios, into a system that allows kind of a seamless transitioning between them. And it's really in response to customer problem statements, that how do I actually go fly this operation? Right? We've been sitting in a room for 5 years talking about building this cool aircraft that could do this operation. Now, how do we actually do it? And it, of course, ties together with the detect and avoid things we've talked about. Being able to communicate reliably to the aircraft means you can send it commands to avoid aircraft. So, it all comes together with this technology that we're building up in this communications C2 CSP communication service provider called Skyline.
And so what you guys are clearly describing is a trend of moving towards more of a mature and robust avionics offering than what the industry has been used to from the beginning, which is some of these more hobby grade avionics. When you look at the installed base of some of these, non-certified, non-robust components that don't really have any kind of design assurance, but they have this tremendous flight experience and flight heritage accumulated across use cases and across platforms. As we move forward into the world where robustness matters and where you fly more safety critical missions and use cases, what happens to this installed base of autopilots in this case? Those have been creeping into the designs to the point where, as I said, they have so much flight experience. Do we as an industry find ways to work around those, or do we rip and replace?
Yeah, I think there's a room in that for what they would call progressive certification, or the safety continuum. We've been working with open source autopilots for years and years, well before this company was begun, and we know there's a great heritage of flight there. Now, we also recognize that the hardware isn't always built to that same standard, and a lot of that reliability and robustness also comes from what type of connectors you put on things and what kind of power systems do you have to regulate your power. And so, we've gone the direction there that, we can add a lot of robustness, and under the durability and reliability certification regime, we can add a lot there, where we're able to take some of those open source software, very carefully configuration controlled, right? Because a key part of this is knowing what you're flying with and knowing that it actually does have millions of hours of flight time and wasn't just built yesterday with no additional verification. But taking that and kind of encasing it in some additional reliability. So we think that's an interesting, good approach. There's also cases where you absolutely need more than that. And you do need more traditional avionics verification, DO 178 verification. And when you start getting into people carrying applications or higher kinetic energies for uncrewed platforms, absolutely, right? There's a spectrum there, but it's not a rip and replace. I think it's really as they upgrade. There's, what makes us uncomfortable are $1 million airframes flying around with a $200 autopilot that, although has in general had very good flight experience and has some probably the best software out there for controlling a variety of airframes, it is also can be susceptible to the connector being plugged and unplugged too many times.
Mm-hmm. DC Capital Partners. So how did it come about? Why did it come about? And how is it helping the business?
We embarked on a search for investment for an acquirer about 1.5 years ago. We began that search, went through a pretty intensive process, and learned so much about the process, but also about our business throughout that process, because you have to ask yourself some hard questions and really fine tune how you talk about yourself and your business to go through that kind of scrutiny that you go through. In the end, we talked a lot about who we wanted to be when we grew up and who we wanted to partner with. Is it a strategic? Is it another investor? Is it a private equity, et cetera? And depending on where we were in that process, we ranged in those answers. In the end, we settled with private equity.
That's great. And I know we want to get into a little bit of lessons for our entrepreneurs, but I saw the Passer announcement. Tell us a little bit about what that was and why that's an exciting new market opportunity for you. And what's it doing for airports?
Well, this is a little bit of a bleed over from my previous history before uAvionix when I was with Harris. Small airports are unbelievably blind when it comes to understanding what's happening in the airspace around them. I mean, most of them aren't towered, so there's not even anyone looking. It's all a cooperative airspace. Yet there are lots of things that occur on the ramps and taxiways of those airports, whether it's snow plows or mowers or utility trucks or the other air traffic that occur, and the coordination occurs entirely through verbal communications over your VHF radio at an uncontrolled airspace, right? So it's by definition kind of a congested environment. It's where all of the aircraft are diverging to or leaving from. So there's traffic in close proximity. And ADS-B, because of the traits that I described earlier, really bring the same benefits to an airport that they do to an aircraft. It's with a single receiver and a capability, they can understand what's in the airspace. With a transmitter on board that snowplow, we can prevent a runway, what's called a runway incursion. So, there are lots of examples of an aircraft landing and taxiing on the runway when there was a ground vehicle on that runway, and catastrophes were averted just by dumb luck. And so it's an increase in safety and capability for small airports, which were previously blind. And then of course there's all sorts of intelligence you can glean from a system that logs the incoming and outgoing flights, who your customers are, where they normally go, where they normally come from. If I'm an FBO, I know customers are coming in and I can fire up my fuel trucks. You can even do things like understand the friction component of your runways right now. Is it getting icy because the runway landings are taking 20% longer than they normally do? There's just so much intelligence you can gather from these systems that, Passer's got a good, we have other partners as well, but, Passer's got a good handle on it as well. So our approach into the airport space, we use the same core technologies, but, we're not out specifically building intelligence platforms for the airports. And so we're partnering with partners like Passer and
That's
others.
great. Yeah. And with Passer's huge market share, you would think it'd be a good opportunity.
Mm-hmm. Yep.
Nice.
Guys, when you think about 2015 founding of uAvionix all the way through acquisition earlier this year, what was that journey like? What was it like to build a company into a success that it exists today? What were some of the highs and lows along that journey that stand out the most?
Pain, hard.
I mean, it's so rewarding, but it's always a lot.
Is the pain the high or the low, Christian? I wasn't sure.
Yeah, I mean, we've had a lot of wins and we've taken a few losses along the way, I think, here. I mean, there's some regulatory decisions that maybe don't go the way you think they should, but we've really worked hard to pivot around and continue to have that upward trajectory on the business, no matter what was going on around us. We've made some pretty critical decision points, including really going all in on our support of the GA market that I think were critical, frankly, to survival, right? That a lot of companies did not have access to or didn't make. And we had the whole time, we've always had excellent advisors. We've had great investors, both in our venture days and now with private equity on board. So we've been pretty lucky, and it's a testament definitely to the team that was built.
The team made the difference. I mean, you could take a different team and give them the same mission and core technology and fail. I mean, it's amazing. I'm amazed and feel lucky to work with folks like Ryan and Paul and Ryan Reed. I mean, there's just incredibly dedicated people who are intelligent and smart, even in industries and things that we don't know about, go learn it and become experts in it. Ryan here on the call, right, has never certified a piece of avionics in his entire career or been in an aviation focused company like this. But Ryan had the mission to go figure out how to certify SkyBeacon. So, and when we got answers about here's how you go certify avionics, we looked at it and said, well, that's not going to work for us. We have to figure out a different way to do it. And so there's a negotiation between the regulator and a startup organization and saying, no, we're not going to do it the way you normally used to it. We're going to do it differently. And somehow we pushed through that. Ryan was the spearhead for that. And just thinking, Paul's concept of, yeah, I can put ADSB in a light bulb, and that's BS, Paul. We can't do that, right? I mean, just the audacity to think you can do something like that, and then pushing it through. So, the team is what made it successful. Wasn't really the market and the flexibility to say, okay, well, rather than going back for another investment round, we're going to diversify into general aviation and start a general aviation line of business, right? I mean, I grew an amazing capacity to grow gray hair throughout this policy, this process, right? I mean, it was so stressful, and
we both have.
It's so rewarding to look back on, but it was every inch of it hard earned for sure.
Was there anything that you wish you knew back then in the early days that you know today?
I think if everyone had a crystal ball of timing of things, you might have pushed different products at different times. There were several instances where we were maybe a little bit ahead of our time with a concept and pushed it maybe a little too hard and got the wrong reaction out of it. The low power ADSB thing was a good example of that, right? I think if the timing of that messaging was a little different, it might have been received differently.
Mm-hmm. I think a lot of those ideas have come around though. So you don't know quite how these things would ripple out. And so I have a really hard time going back and picking things that in isolation seemed good, might cause ripples that you didn't want. And I mean, things like those low power ADSB and inert and alert and different frequencies and all of that are coming around, in some of these international environments again. So it's hard to say. I mean, we've had challenges and things along. Christian alluded to, certification of SkyBeacon that were dead stop. These things will not work type of challenges that we got around. And had we known to take an alternate approach first, the second approach might not have worked properly because we didn't know enough. So, I just think it's one of those companies that we've been incredibly blessed to make the right pivots at the right time. And it, I attribute a lot of that to instinct, especially Paul, our founder's instinct. I think at any company, if you're looking at lessons around this, it's that we've listened to our customers pretty well. I think interpreted what they needed and trusted our instincts and how to get there with it.
If you guys fast forward 5 years and then even 10 years, what does the industry look like?
I think in 5 years we should be seeing broader scale delivery services happening. We're seeing success in small scale from Wing, particularly Matternet's type certification. I think the pieces are now falling into place. Many of us who live in certain geographies, to start to see that become a reality, I guess that would be 10 or 12 years after Jeff Bezos' original prediction. But I think that should be occurring more regularly. I feel like the regulatory pieces that have been pushed are really sort of all falling into place, and there's enough momentum for that to occur. Unfortunately, I think we still will see some additional consolidation in the industry, whether it's through acquisitions or some companies not weathering the delays. I think we saw another one this week, right? So I think that will continue to occur. And in 10 years is a lot harder to predict. I still don't know if we'll see people carrying systems in 10 years. I just don't know if we'll get through a type certification of a brand new aircraft type and commercial operations, but I hope I'm wrong with that.
Guys, you've kind of touched upon it, but you have a huge audience right now of entrepreneurs in aviation technology, and they're listening to any nugget that they can take to help launch their business or grow their smaller businesses. What are the three things you would teach them or you would tell them?
Well, I can tell you one is, make a decision. If you're lucky enough to go and get some initial investors and get some funding for your first few years, make a decision to become operationally sound on your own so that you're not stuck in that environment where you have to keep going back for more. That was one of the big decisions we made after our second round of funding, and we entered into the general aviation market, was we didn't want to go back unless we had a seriously killer moonshot, huge investment idea that we were, sound in, right? Become your own company, and that gives you a lot of freedom.
And that's always been a bit of a pet peeve of mine. I've been involved in a lot of startups and I've seen it go both ways. And we, as a team had a high level of agreement on that, call it a conservative approach. It doesn't mean you have to be real conservative in your market growth. If you have a good product, people will come to you. But, we've spent a lot of effort on engineering, core R&D efforts to build that product before we brought on that successive phase. And I've worked a lot of companies that, the lawyers and the sales teams outnumbered engineering far before any product was ready to deliver, and that's not generally been a sign of success. So we've tried to build that responsibly, and it worked out well for us in this case. And that's a credit again to the team. So that team is the number one thing to look for, and that team is not just your internal team, but those investors that you bring on. Again, we had great advisors and investors who were able to, I think, give us a leg up in a lot of the things that we did, open a lot of doors for us. And if you can start some of those conversations with people, especially if you're new to an industry, there's nothing better.
Who do you look to for a thought leader in this industry?
I don't want to say I'm jaded, right? But there's just been a lot of noise in the industry, and it's the more quiet executors that I respect, those that aren't the most outspoken folks. I mean, you see the same names bouncing around at different companies, and I don't feel like the concept of sort of celebrity CEOs is kind of there's been a few of those in our industry, and I don't have the greatest regard for those folks.
Yeah, there's a lot of hard work that goes down in the trenches, and I think more than just individuals, there are groups that we put a lot of credibility towards, and some of those are the standards groups that are working very hard, and it's a lot of people behind the scenes, and the names that Christian and I might throw are so obscure that they wouldn't rate, but they're the people who a lot of time are working, slogging through, really trying to create these specifications that 10 years later are implemented by someone, but that we know had a lot of forethought to be able to create those things. So because we're so ingrained in that side of the business, and we come to interpret some of those things, that I think some of the groups out there really have done a great job.
I'll tell you a company I like to watch, is Anduril, which is a defense organization that is a non-traditional defense company that is just making tons of waves in this space, because their approach has not been go get the government funding for iterative R&D over time. Their approach is, I'm going to build a kick-ass product so good that the government's going to have to buy it. And they've just come out with really, really cool things. So, similar in concept, but on a way different scale than, the way we try to operate. I think that's a really neat company to model.
Is there one point that you would want our audience to most take away from your comments?
I think we tried to be the educated voice in the room, the reasonable voice in the room, and we try to represent the entire swath of aviation and airspace users. We spoke a lot today about general aviation and drones, but I've said before, we're all pilots. I've been on aviation technologies from the regulator perspective with the ADS-B network. I've been involved in airport-focused products and services. I've been involved in flight training devices. We've got helicopter pilots. We've got very broad breadth. And so we tried to come across as a credible voice when we're in these rooms and talking and try to skip the hype. And I think that may have slowed us down a bit in past years, but I think, as Ryan said, those concepts are coming back. We tried the other things, and now we're coming back to the reasonable and balanced approaches that we've been talking about for a long time.
We were told pretty early on by some of the biggest players as we went to these meetings when we were really just a very small startup. They said you don't recognize the power that you have in these conversations. You're new to the space. You're bringing fresh ideas, and there's a desire. As much as we talk about how much inertia there is in some of the industry, there is really a desire that everybody does want to move forward.
Well, guys, thank you very much. Well, first of all, for the innovation that you're bringing into the industry. Second of all, for sponsoring this podcast. And third of all, for being here today and talking to us. Really appreciate it.
Thanks, Luca. Thanks, Jim. It's been a real
Thanks,
pleasure.
guys.
Thanks, guys.
All right, that's a wrap for today. Thank you for listening to the Vertical Space Podcast. Reach out if there are topics that you would like us to discuss, and goodbye until the next episode. Unless mentioned, this podcast is in no way endorsing or promoting any person and or company mentioned, and all opinions within the podcast are solely that of the presenters. The Vertical Space makes no guarantees, warranty, or representation of any information given in this podcast. Any information given is for informational purposes and should be used at your own risk. This podcast is for general, educational, and entertainment purposes only.